We're going to go really fast today. Who's seen any of my talks before? Anyone? Oh, there's some people. Cool, cool. Good to go. All right. Hey, I'm James. Hi, everyone. Thank you for coming. It's a full crowd. Did you put the full sign? Should let more people in. The FOSDEM, there's room in the sides. Yeah? So, should we let some more people in? Quickly, let them in. Let them in. So, who am I? I'm a hacker. I work on config management stuff. I write a technical blog called the Technical Blog of James. Who's seen my blog? Just raise your hand. If you haven't, just raise your hand so I seem really popular. Is that Richard Jones? Is he here? Is that Richard? Anyways, I used to work in physiology, or I studied as a physiologist, so if you have any cardiology questions, just let me know. And big into DevOps stuff. I was working in DevOps, and all the tools were just this, everything was on fire and terrible. And, you know, people were like, we had all these servers, but now we have VMs, so let's manage some VMs. But then, like, oh no, now we just have more of these machines, and it's a big disaster. And now there's all these fancy pieces of software to deal with these things, like, I won't name any names. And the real question is, do we want to really use these giant and flexible monoliths to manage our VMs? Do we? Don't be shy. So this is the answer to that as far as I'm concerned. This is my nope guy. Just like, I don't know. Some people might enjoy those pieces of software. For me, it was not what I was looking for. And that's fine. You use the things you want to use. But I wanted to see if I could do this in a better way. So long story short, I reluctantly sat down and started writing some code. We have a project called Mgmt. We've got this lovely logo. Thank you. And Mgmt has two main parts. There's the engine and the language. The engine is basically what actually does the work, and the language I'm going to talk about a bit too. So in the engine, just really quickly, I'm going to go very fast. So if I'm going too fast, hopefully you can slow down the video at the end and watch everything. So the engine actually has two parts. The engine has three main design points. The graph of resources that it runs in parallel. They're event-driven, and it works as a distributed system. So basically, for this sort of thing, we have these DAGs, these resource graphs, and each blue block is work that we want to have done. And the black arrows represent the dependency between each thing that we want to do. And if you can see this red line here, it's something called a topological sort, where we just basically decide we're going to do this and then that and so on. But in MGMT, instead of wasting a lot of time the way most other tools do, we can actually parallelize this. So everything on the left can actually be run at everything on the right. And so even 1A, once this is done, we can do these two resources and so on. Does that make sense? Pretty basic stuff. And that's useful if we're working on really big, complex systems that have a lot of things going at the same time. We want them to be able to run in parallel. And each box, each of those blue boxes, those resources, are actually event-driven. So I'm going to actually show you a quick example of this. We have all sorts of resources, including a vert resource. So I'm just going to sit down to do some demos. So don't worry, I'm still here. Don't be afraid. I'm just going to run this first demo here. And basically, it's very simple. I'll show you the code. It's very, very simple. We basically just declare to the, oh, you can't see it there, but we declare this vert resource, and we give it some properties. So one CPU, memory that we want it to be running, and so on. And so let's just run this and see what happens. So we're going to run this over here. And if we run versh list, can everyone see? Is that big enough on the right? So you can see that MGMT started up this VM right here. It's running. But here's the cool thing. Everything's reactive. So if I just destroy the VM, you can see MGMT says, hey, you were supposed to have that running. So it automatically starts it back up, and you can see it's running again. So you can destroy it, comes right back up. Cool. You can even, I think you can even undefine it, which is another VM thing. Oops. And no, that one you can't because it's transient. But yeah, so you just do bad things to it, and MGMT will fix the state. Make sense? So that's just the basics. You want to do some fancier stuff? Yeah? Yeah? All right, cool. All right. So I just want to check. So now we can actually kill it, and it's going to go away. So, so this is actually what I think is config management, but this is really another technology as well. Does anyone know what I'm getting at? I think this is monitoring, right? So traditionally, sysadmins would like set up all this infrastructure, but then you have to set up monitoring, detect what's happening. This way, it kind of merges the two in the same bunch of work. So hopefully, you don't have to replicate too much work. So now I'm going to switch very quickly and talk about the language. So this is sort of the design principle for the language. We want to express things that are very, very complicated in very, very safe ways, hopefully. So a safe language, we want it to be very powerful. So we use something called a reactive language. And we want the language to also be very easy to reason about. So our language is a DSL, so it's a domain-specific language, which means the language is useful for infrastructure automation, but it's not useful for general-purpose programming. It's designed for this use case. And because it's very specific to this use case, it has some special magic powers that other languages would find it very hard to write. So here's a demo I'm going to show you. Just to show you the example, so we have this date-time function, which is in the language. And we add the output of that to this a year variable. And then over here, there's like this a year variable is a bunch of numbers multiplied together. And then we put that into a struct with this load function, which then takes this value and goes in here. And this is all super weird. And then all of these, we build this big string and then stick it into this file. What is going on here? Does anyone know? Looks a little confusing. So let's run this code just to see what happens. So I'm going to run that code here on the left. And again, that whole thing just produced a file. And I'm just going to actually just, I'm going to run this watch command to show you the output of that file in real time so you can see what's happening. And you can see that the output of the file is changing all the time, right? And here's why. These variables and these functions, this function here, this datetime, doesn't return the date time. It returns a stream of the datetime values. So every second, this actually changes. It's the number of seconds since 1970, right? So this changes every second, which means this variable changes every second, which means this variable changes, and so on. The load value comes from the kernel. The kernel decides that the load is, they recompute it every 5 seconds, so that will change. And all of this stuff gets output into this string. And then the engine gets these resources that it builds, and it happens in this particular graph that those resources are changing every second, which is the file contents, and that's what we see. So we can see this ticking away, and that's changing in real time. Does everyone follow that? And just to make this a little bit more fun, I have actually this VU function, and what the VU function is actually doing is actually listening on my real laptop microphone right now and sampling the sound. And if you look, it's printing out a little graph to express that. So if we're very quiet, see, it goes up. And if you want to test this, I'm going to be really quiet, and when I point at you, I want to hear you make a lot of noise. Are you ready? There you go. So again, any value, any sort of string, you can build all sorts of inputs that are changing over time. It's really up to you to be creative. And I kind of use this example a lot because it's a bit of a joke, but you could have this in your server room, building your real-time infrastructure. If the volume is too loud for some number of seconds, maybe people are having a fight, so you could automatically set all your file systems as read-only so that sysadmins don't break things. Yeah, random things like that. Whatever you want, that's the idea. Does that make sense about the reactive? You want to see more demos, or you had enough? Yeah, okay, let's going to make this a little bit more complicated. So, magic CPUs. So here's what I'm going to do. First, what I'm going to do is I showed you I had that vert resource, right? So I have another one, and I'm going to start up MGMT on my local laptop. And I just want to make sure I start up the right one. So I'm going to start up MGMT, and what it's going to do is I'm going to run virsh list. So it started up MGMT some VM. And let's actually log into that VM. Now, normally when you have a VM startup, it's already been started up. That was fast. Normally, my password is password. Normally when you have a VM startup, you might want it to automatically start MGMT and then run itself inside the VM as well. But because I want you to see the logs of what's happening, I'm actually going to run MGMT in a terminal so you can actually see what's happening instead of doing it automatically. And the way I do that, I just have the same thing. I'm just going to run MGMT. I just have a little script that runs it up. So what I have here on the left, I have MGMT running on my host, which declared the state of one VM to be running. And then inside that VM on the right, I have just the console of what's happening. And here's the fun part. Here's what I'm going to do. I'm going to tell you the trick, and then I'm going to show you what happened. So the VM resource, remember, it's declarative. So I say I want this number of CPUs, this much RAM, and so on. But if I tell MGMT that that value should be 2 instead of 1 for the number of CPUs, MGMT will notice that the user requested a different value. And in the case of virtual CPUs, it will hot plug or hot unplug the CPU count in that running VM. So in real time, in seconds, you can hot plug or hot unplug by just changing the number. And to get that number, I have a little text file that MGMT is watching. So just the way I had a sound microphone input, in this case, I have a little CPU count text file that just says a number, and MGMT is taking the value, the integer from that file as the input. Now, that's part one. So when this value changes, it hot plugs or hot unplugs CPU. In the VM, MGMT is also running, and MGMT also can use the CPU count as a function. So it has a function called CPU count, and it reads how many CPUs there are. And so I'm just going to hide this over here and open up a new window. I have a little display CPUs shell script, and it's just looping, and it's doing two things. One, it's running lsCPU, so you can see how many CPUs the kernel is exporting. The other thing is it's editing a file to put in the number of CPUs. This could be doing something fancier, but it's just for simple. So I'm going to ask it to hot plug a CPU or hot unplug. It'll change the CPUs, and then on the right, it should react very quickly and respond. Does that make sense? Let's hope that, should we see if this works? Okay, so I'm just going to echo, say 1 CPU count, and boom, it's done. See that? If we change it to 2, it goes to 2. We could go to 4 if we wanted. So very quickly it responds, and then instantly we see 4 CPUs. Is that cool? You want to do it faster? Faster, or you've had enough? You guys are a shy audience. Who's shy? Just raise your hand so we know where you are. Anybody? All right. So I actually can do this faster. So I made a little crappy shell script over here, and all it does is the shell script, when I press plus or minus, it just echoes to that file 1, 2, 3, or 4, just so you can see how fast it goes. So I'll move this over here, and just as I press 1, you can see basically in virtually a second it goes up. Isn't that fast? Is that cool? No. That virtualization? Can VMware do this? I don't remember if that's a feature or not. And so what, apart from cool demos, maybe that's too ego-y, but like the reason this is useful is because imagine you have some big host running a whole bunch of stuff, and you just squish all those VMs together, because most people have their crappy website about their cat that never gets visited, until that one day when there's a lot of traffic. So then the load goes up, so you dynamically see that the load is going up, so you add more virtual CPUs, and inside the thing you schedule more services to start and deal with that load and do all sorts of stuff like that. Is that cool? Yep. And that's the point. You have a quick question, sir? Can it be used for what? Fencing? I don't know. Yeah. Wait. I have more demos, so I'll show you. I think answer. I got a lot of demos. So quickly, we can do everything. Actually, we haven't implemented it for RAM because it's really hard. If you will help, I'll help you right at the RAM support. It's trickier. The CPUs work really great. The RAM is like a bit sketchy and there's some bugs, but it's doable. So, do you want to see some more demos? I have some more cool. So I'm just going to shut this down. You actually have to kill MGMT before you shut it down. Otherwise, it will just start it up again, right? So I can shut that down. So I showed you some Magic D demo stuff. This I'm going to skip. So really quickly, what I'm not going to show you a demo is this language, this FRP language, can actually look at the historical values that a variable had. So I know what the load is today, but I also know what the load was 5 seconds ago or 10 seconds ago or whenever. So what is this lovely photo of? Anybody? Scream it out. It's a thermostat. This is my parents' thermostat in Canada. You can see it's in the correct international units of Celsius. I found a prettier picture for some sort of weird US thermostat. I don't know what the units are, but I think they have their house far too hot, just for clarity. And this thermostat has an interesting property. Does anyone know what it is? I found the hecklers. Anyone know what the property is? The property is called hysteresis. And what hysteresis is basically when you, let's say you want to have your house heated to 20 Celsius, the temperature is going to go up, and the moment it hits 20 Celsius, oh, it's going to click off. But then it drops down 0.1 degrees, and it clicks back on, and then back off, and back on, and back off. And if it was doing this rapid oscillation, you would hear all this clicking, and it potentially break your furnace, and it's not good. So what hysteresis lets you do is when you hit a threshold, you can delay some time or distance before you click back on. And we're going to show you how that's useful. Want to see a demo? Yeah. Come on, do you want to see a demo? Yeah. Okay, it's the end of the day. I'm tired. I'm sorry. So, where's that demo? What was the demo? So, I have this demo. So I'm going to run the demo on the left. It's running. I can show you the code if you want. All the code, it's all in Git. So you can try these demos at home on your own laptops. And just to sort of show what's going on, I'm going to run this watch command on the right. So it's basically just every half a second, it's catting some text file, and then running echo just to put a new line. And then it's running virsh, which is the VM list command with libvirt, listing over and over again. Make sense? So you can see what's running. We got 2 VMs running, 1 and 2, and MGMT is running here. And what I've done, you can see right here, I'm printing out the system load in that text file, and I'm also showing you a threshold of 1.5. So when the threshold gets above 1.5, I've told it to shut down one of the VMs, and then only when the threshold stays below 1.5 for 10 seconds will it start up that VM again. Does that make sense? And we'll talk about why this is useful after. So I'm just going to move this down here. So watch. So I'm just going to just artificially increase the load just to sort of show you that something is happening. And watch the value go up. It's going up pretty fast. So watch, the second it hits 1.5, there's actually a bug in this, so I hope I didn't hit the bug. There we go. See, it hit 1.7, and you see how MGMT2, the second VM, shut down? You see that? Yeah. So watch. So the load is still high. Now watch what happens when it goes below 1.5. Nothing's going to happen for 10 seconds, hopefully. So it's at 1.6, it's dropping. 1.6, 1.500, so not quite or so. So 5 seconds, I don't know where the rounding error is. Okay, so in 5 seconds, 4, 3, 2, 1, there we go, and it started right back up. Is that cool? You like that? You can clap if you want. Okay. So obviously the implications are pretty obvious. You have a whole bunch of load on a whole bunch of machines. You reschedule them somewhere else and so on. And like trying to buy the VMware plugin to do this would be like $1 million, and who knows how it works. So the whole point of having this light, flexible language is that you can build these dynamic systems in real time that do what you want. And say you're one of those scared people that doesn't want to touch code. First of all, you're crazy. But second of all, you don't have to. Someone else could build a module for your company that does the use cases of a bunch of things. So instead of building this huge Kubernetes or OpenStack monolith or whatever, someone would just build a small MGMT module that's customized for, you know, a whole bunch of use cases. And if you want those use cases, it's a month of work for some developer to build the thing for you, and a different month for a different kind of product and so on. So fast, dynamic, right? I think that's how software should be. So I have more stuff to show you, unless you're fed up. You want to see more? Yeah. That was better. That was better. This is FOSDEM, everybody. Okay, so hysteresis. So some interesting nerd properties. The language and engine. The language is something called an FRP. I'm not a genius at FRPs, so I'm kind of making it up as I go along. But the cool thing is the language in theory shouldn't crash, but it actually can because like of runtime errors, like a hardware failure or something like that. But technically, we're trying to eliminate all sorts of errors at runtime. But even if there was a runtime error in the language is actually pushing a stream of graphs to the engine that does the work. So worst case scenario, worst case scenario, the engine would just be sitting there without a new graph for a while. So not perfect. Remember how the code was out of order? It's a little strange, but that's actually because the code is a graph, like in the graph DAG sense of the form. So you could write code that's out of order and it will still work properly. You probably shouldn't do this because you would be insane, but just a weird sort of quirk about the language. We add a lot of safety properties into this because we don't want you to blow away a data center because you made a bug. So variables are immutable. So if you did x equals 5 and then x equals 7, this would be a compile time error. Right? There's no nil variables in the language, so you cannot set something that's like a nil pointer exception or anything bad like that. I talked about hysteresis. There's different kinds, and you can use this to make all sorts of complex decisions. Hysteresis is useful because it's a real life thing that we like, you know, think about. Like imagine like, oh, I'm going to open this door. The door handle is hot. Huh. Okay, I'm not going to touch it again right away. Right? Your brain has all these ideas. Something's not working now. You think about it. It's a real life thing. Reactive variables, super useful. Eventually, we could probably also model error scenarios as reactive variables. I don't really want to talk about that because it's kind of niche, but I'm talking at a really much more technical niche conference in 2 days. So there's going to be stuff about that if you're interested. And if you're into graphs, our import module system is actually a DAG, and it's this new system I just built to do all the module writing, so you could actually build these huge standalone components. It worked out really elegantly. I'm very proud of it, and all upstream. So if you want to take a look, excuse me. So there's a lot of stuff still to do. How much time do I have, Mr. Timekeeper?
6 minutes.
6 minutes. So I don't have time to show you another demo, unfortunately, but I'll just tell you a bit more about the tool. So we still need stuff to do. It's still new in the project. We're really on the borderline of being production ready. You could probably start using this for a lot of simple use cases, even just doing a small VM automation project, something that you couldn't do with your traditional tools. Play with this. We have an Amazon EC2 resource if you want to manage VM in the cloud thing, wherever that is. So same sort of stuff. If someone deletes your EC2 instance, it will bring it right back. You can shuffle them around. We have a scheduler that works in real time, so you can actually move VMs from cloud to other cloud or from EC2 to some other guy's cloud if you want to. So think about all these things. New features, still a lot of stuff to do. There's some bugs and things there's some code quality stuff that I think it's probably fine, but it probably needs a little bit of love. And this is all about, excuse me, this is all about you. How can you help? You can use this, test it, patch it, share it with your friends, document it, start it on GitHub if you're into that kind of thing. You can write a blog post about it, even if you don't code, like, this was cool. You can tweet it if you have Twitter. You can discuss it with people in the hallways. Hey, that purple idea guy is pretty cool. Hack on it. Just hack on this stuff, right? It's code. It's out there. I left a job at a reasonably cool tech company to sort of live off my savings and do this, and I'm trying to keep it all free software. And that's the goal. But if I don't have people sending patches or sending me money, eventually I'll have to stop or make it proprietary. And that sort of sucks. We don't have funding. I'm just like graph of my money going downward. So I have a Patreon just for fun. That's me. And like funding a hacker, it's very sexy. So if you want to feel sexy, send me some money. That's cool. Let's just recap. You can't hear the audio, but it's Arthur Benjamin putting the cap back on his pen. It's a really bad joke. I reuse all my jokes, so I'm sorry about that. IRC, Mgmt Config on Freenode. We hang out, talk about nerdy things. There's a Twitter account and a mailing list hosted by my former employer. There's the technical blog of James. You all know about it now, so you can check that out. RSS in the house. I'm Purple Idea on IRC and Twitter and so on. And if some crazy person accepted all of my FOSDEM talks except for the main track stuff. So I'm giving a talk tomorrow. These are some talks I gave earlier today because everyone just accepted the talks and it was kind of absurd. So I'm going to talk about the same sort of thing but with container scheduling. So I'm going to do a scheduling demo so you can actually schedule containers very easily. You don't have to have a whole container thingy. And then there's a small lightning talk which you might not find interesting. Right after FOSDEM on the 4th, I'm at Config Management Camp where I'm going to give a really hard talk and then a really, really hard talk. And also Felix Frank did some cool work in MGM2 who's going to be presenting as well. So that's free if you can come, if you can get a spot, like you should come. And on the last day, on the 6th, in Ghent, 30 minutes away, I'm holding a hackathon. So all day we'll be writing MGMT code, playing with it, diving in, new users, experienced users. Everybody's going to be there, hacking away. It's free, so if you can come, feel free to. Feedback. If you like this talk, please find a FOSDEM organizer in the yellow shirts and go up to them and be like, hey, like James's talk, Purple Idea, was really cool. And if everyone goes up to them, that'd be awesome. If you can't, go to the schedule page on the website. There's a secret link. If you click on the talk at the bottom, submit feedback. This is real. Go click on it and say, hey, his talk was awesome. And then maybe they'll be like, hey, we should have him for a main track talk. Because then you get a free hotel, and that's awesome. So I'm almost out of time. I have some very expensive stickers I will give you. If you promise to use them and stick them on your laptops, then you can have a cool laptop like mine. So if you want a sticker, I'll be just over here outside, and I'll give you one. And that's really that. Thank you very much. So I have like a few minutes. Wait, 2 minutes. If you want a question or two, I will find it. I think the famous, if you haven't met him, Richard Jones is in the audience. He's a famous hacker that makes all the plumbing stuff, like all the vert magic, all these things aren't possible. I didn't write all the things underneath MGMT. So guys like him do great work to make these things possible, the systemd people and so on. So bother Richard because he's shy, but he's a genius. And he helped me on the FRP path. So yeah, questions? Any questions? I can take, yeah, go ahead. So the question is which hypervisors are supported. So we actually wrap libvirt. So anything that libvirt supports theoretically works. I only test with like QEMU stuff and like KVM, like the core Linux stuff. It's known to work with others, but I don't really know. Technically, it also works with LXC, but I've never really tried it. And if you have a bug, like submit it. It's probably going to be a libvirt bug. Yeah, go ahead.
Please close the door.
How do you measure it? Sorry?
How do you know the load? Is it a quality system? How do you know that the event doesn't exist anymore? Is it fit?
Yeah.
Fit or is it event driven?
So the event driven, there's two basically event stuff. The resources, each resource, the question was about events basically. So the resources themselves have events to know when their state changes, which is so that the engine can change the state or run the state, whatever. The second source of events is in the language. So those functions like date, time, and so on, those suck in events from something. So anything you want to have events from needs somewhere to get it. So in the case of libvirt, the libvirt daemon actually is watching the state of each VM, and that's where it gets its information from. Does that answer your question?
How about the load?
The load? The load comes from the kernel. So the kernel has a thing.
You need to pull it.
No, look at the code. It's amazing. It just pops out a new value every 5 seconds. I don't think it's polling, but pretty sure. I'll check. But yeah, any value you want. There's almost nowhere that we're actually polling. I have to go, but I'll be right here if you have any more questions, and come up and I'll give you a sticker. Thank you so much.
Awesome talk.